Today's step question is on the solution of polynomial equations, specifically a quartic equation, and there are lots of surds thrown in, which for a paper that doesn't allow the use of calculators can be a challenge. This question is from Step 1, 2019, and there is a first part, which is to find integers m and n so that the square root of 3 plus 2 root 2 equals m plus 2 root n. This part is used later in the question. So we start by writing down the expression we're solving. Square both sides. 3 plus 2 root 2 equals m plus n root 2 squared. Square that using the binomial expansion and then compare the two sides. So the root bit, the surd bit on the right, will equal the surd bit on the left, and the non-surd bit on the right will equal the non-surd bit on the left. And there is an easy solution to these, which is that m is 1 and n is 1, which is easily checked to be correct. That will get you the marks. There is another solution to these two equations, which is m equals minus 1 and n equals minus 1. We don't want that here. We're going for the positive square root. And the moral of this is, when you're solving equations that involve squaring both sides, check your solutions fit the original equation, because occasionally you get roots which don't fit the original when you square on the way. Squaring is not necessarily a reversible operation. Anyhow, on to the meat of the question, part 2. We're given a function f of x, which is a quartic, x to the 4 minus 10x squared plus 12x take 2. You'll notice straight away that there's no x cubed term, or rather the x cubed term is 0. We're given that this has 4 real roots, the equation, and we need to explain why it can be written in this form. So we need to explain carefully why this can be done. So one way of dealing with this is to say that the 4 roots are, we might say alpha, beta, gamma and delta, letters often used for roots, and then write this as 4 factors. X take alpha, x take beta, x take gamma, x take delta. Since we're looking for 2 quadratics, we multiply the first 2 of these to get x squared, subtract alpha plus beta x, add alpha beta, and for the other one, x squared take gamma plus delta x plus gamma delta. We need to explain why the coefficients of x are negatives of each other. Since the x cubed term is 0, the sum of the roots is 0. Alpha plus gamma plus beta plus delta equals 0. Therefore, alpha plus beta equals minus gamma plus delta, which is why we have s and minus s. S is just a letter standing for alpha plus beta. So we have now the s and the minus s. Alpha beta is just a number, call it p. Gamma delta is a number, call it q. We have the expression as required. I think it would be the case that some candidates here wouldn't be really clear enough about getting this first expression. They would just use it and work from it, and although that would get you subsequent marks, it wouldn't get you the marks for this part. P, Q and S are all real numbers because alpha and beta and gamma and delta are. That's worth saying because it does say in the question real P, Q and S. Okay, now let's compare the two sides. Compare the expression for f of x with what we have just got. Looking at the x squareds, we have p plus q minus s squared on the right, and we have minus 10 on the left, which gives us one equation. Looking at the x's, we have 12 on the left, and on the right it will be sq minus ps. And for the numbers, the unattached numbers, we have minus 2 on the left and pq on the right. So 3 equations. We now need to take those equations and derive this expression here with s squared in it. So we're going to eliminate p and q from these three equations. And when we've done that, we're then going to find s squared. So one way of doing this, it's not the only way, is to note from the first equation that p plus q equals s squared take 10. From the second one, that q take p equals 12 divided by s. So adding the two equations will give us 2q, and subtracting will give us 2p, two expressions here. Multiply them together to get 4pq will equal the two right-hand sides squared, which is a difference of two squares. So s squared take 10 squared minus 12 squared over s squared. Use equation 3 to replace pq by minus 2. We get minus 8 equals the right-hand side. Multiply by s squared and rearrange. We get the required expression. S squared minus 10 squared, add 8s squared minus 144 equals 0. The question now asks us to find s squared. What we have here is essentially a cubic in s squared. You could replace s squared by a letter, like u, but you don't have to. So multiplying out the equation, we get this order 6 equation in s to the 6, essentially a cubic. It factorizes using the factor theorem to s squared minus 12, s squared minus 2, s squared minus 6. So s squared equals 2, 6, or 12. It now says in the question to use the smallest value of s squared that you have got. It doesn't give us the values of s squared, so if you've got the wrong value, at this stage you could go totally wrong and get bogged down. But we have the right value and we're going to use s squared is 2. It says completely solve the equation f of x equals 0. So s squared equals 2, so s is root 2 or minus root 2. We need to find p and q and then solve the equation. So s squared equals root 2. We'll take the positive value for now and work backwards to find p and q. So put it into here. Q plus p equals minus 8. Q take p is 12 over root 2. Solve that. We get p equals minus 4 take 3 root 2, and q equals minus 4 plus 3 root 2. If you'd taken instead s equals minus root 2, you would have got p and q the other way round, which means when you write fx out in full with known numbers, you would simply have got the two brackets the other way round. We now need to solve fx equals 0. We have two quadratics to deal with. So the first one, we need to solve this. This is non-calculator, so either complete the square or use the formula. Using the formula, we get minus root 2 plus or minus root of 18 plus 12 root 2 over 2. What is this square root of 18 plus 12 root 2? Take out root 6, we get root 6 times root of 3 plus 2 root 2, which is something we did in part 1 of the question and got 1 plus root 2. So here we have root 6 plus root 12, and our final values are x equals minus root 2 plus or minus root 6 add root 12 over 2. That doesn't particularly simplify. We do the same for the other quadratic. This time we have root 2 plus or minus the square root of 2 plus 4, 4 take 3 root 2 over 2, and we're square rooting 3 take 2 root 2. Analogously to part 1, that gives us 1 take root 2, so we get the final answer of root 2 plus or minus root 6 take root 12 over 2. So we have 4 distinct solutions to this quartic equation which are expressed in terms of root 2, root 6 and root 12. So a nice question there that has involved solving quadratic equations, plenty of surds, a disguised cubic and something on roots of equations. Preliminary work for this question might have been use of surds, the sum and product of roots of equations, solving simultaneous quadratic linear equations, and factorising cubics and quartics, all useful A-level material which is relevant to this question. So that's this week's step question. Come again next week for another one of these step questions. For now, this is Gold Standard Maths, and I'm David Forster.